How rutile forms. By popular demand, we're doing rutile, which is a mineral composed predominantly of titanium dioxide. It's a remarkable substance found in various different geological formations, and understanding how rutile forms can actually provide very unique insight into the complex processes that shape the planet's crust. So, let me break down exactly how rutile forms in 5 beginner-friendly steps. Ready? Titanium-rich rocks, concentration of titanium, chemical reactions, crystallization, and geological events. To begin with, rutile is typically going to form in igneous or metamorphic rocks that are very rich in titanium. These rocks are going to originate from the cooling and then solidification of magma, or the alteration of pre-existing rocks under very high temperature or pressure conditions. During the formation of igneous rocks, titanium-bearing minerals such as ilmenite and titanite crystallize along with other minerals as magma cools and solidifies. In metamorphic environments, pre-existing rocks undergo recrystallization under the influence of heat and pressure, leading to the formation of new minerals rich in titanium. These initial formations serve as kind of precursors for rutile formation. Now it's important to look at the concentration of titanium, because geological processes such as weathering and erosion and sedimentation play a crucial role in concentrating titanium-bearing minerals in very specific areas. As rocks containing titanium minerals undergo weathering and erosion, they're going to release their mineral constituents into the surrounding environment. Titanium minerals, being relatively dense, tend to accumulate in sedimentary environments such as beaches, riverbeds, and deltas, where they concentrate through sorting processes driven by water or maybe wind. Over time, this concentration results in the formation of economically viable titanium deposits, which serve as potential sources for rutile and other titanium-rich minerals. Now, in the presence of oxygen and water, titanium minerals can undergo chemical reactions that promote this transformation of precursor minerals into rutile. These reactions can occur through processes such as oxidation, hydration, or hydrothermal alteration, which is a posh word for saying water changes things. For example, in sedimentary environments, the oxidation of iron-bearing minerals releases free oxygen, which can react with titanium minerals to form rutile. Similarly, hydrothermal fluids rich in silica and titanium can essentially facilitate the replacement of existing minerals with rutile through metasomatic processes. These chemical reactions occur gradually over time, leading to the formation of rutile-rich mineral assemblages. And don't worry, if the term metasomatic threw you, it essentially just means rocks swapping stuff with water. Now, this is where it's going to start to crystallize, because under suitable temperature and pressure conditions, the chemical constituents necessary for rutile formation are going to arrange themselves into orderly crystal structures. This crystallization process typically occurs during the cooling and solidification of hydrothermal fluids or the recrystallization of metamorphic rocks. Rutile typically crystallizes in the tetragonal crystal system, forming these elongated prismatic or even needle-like crystals. The orientation and size of these crystals can vary enormously depending on the specific geological conditions under which they've actually formed. The crystallization is a critical step in the formation of rutile itself, as this determines the mineral's physical and optical properties. Now, I'm going to finish with geological events, and I'm also going to briefly touch on how it forms as an inclusion, because I know if I don't mention this, people will bring it up curiously in the comments. So, geological events such as tectonic movements, volcanic eruptions, or maybe metamorphic processes might further influence the formation and distribution of rutile-bearing rocks. It's these events that can introduce additional pressure and temperature variations, impacting the crystallization and stability of rutile within the Earth's crust. Now, as many of you are going to be aware, rutile often forms as an inclusion, so in other words, forms inside other crystals, and it usually does this during these processes. For example, during metamorphism, rutile might nucleate within minerals like garnet or quartz, creating very distinctive patterns or textures known as rutile needles or occasionally silk. It's these inclusions that provide very unique insight into the conditions under which rutile actually forms, and also the geological history of the host rock that it's found in. Let us know in the comments any crystals, minerals, or precious metals you'd like us to cover next.